In this video, we're going to talk about how to take derivatives and integrals of exponential functions or logarithms that do not have a base of e. So we're not talking about the natural log, we're talking about common logs. And instead of an e to the x, we're talking about something like 5 to the x or 2 to the x. So be sure you set up your paper for Cornell Notes. These are the formulas that were discussed in the first video you should have watched, which was derivatives of exponential functions part 2. Okay, so you should already have these formulas, but you will need to make flashcards, so you might need to stop the video and make the flashcards now. Here are two new flashcards you will need, and this is what happens when we're finding the derivative of a log that's not an ln. It's a log with a base something other than e. So you'll notice, remember the formula for the derivative of ln x was 1 over x. And just like with the a to the x and the a to the u, if your base is not an e, or if it's not a natural log, we have to adjust our formula. So instead of 1 over x, we now have 1 over ln of a times x. The ln of a comes from the base. Okay, if our function is not just an x, we're going to use u to represent another function, then we have to use a chain rule process, and that's where the times du dx comes in on the second formula. Let's look at two examples that deal with these two formulas. Okay, so for the first one, we're taking the derivative of log of cosine x. So this is one where we're going to have the form a log base something of u. And our u is our cosine of x. In this problem, the base is not given. So on a regular common log, when the base is not given, it's understood to be a 10. So go ahead and write in the 10. Okay, now your formula says the log base a of u is going to be 1 over the ln of a, and in this case our a is 10, okay, times the u, which is cosine of x. And then, because it was cosine of x and not just an x, we need to also multiply times the derivative of our u. So the derivative of cosine x is negative sine x. We can clean this up a little bit by making this into one fraction. And I'm actually going to split the trig away from the 1 over ln of 10. So I'm going to write 1 over ln of 10, just like it is. And the negative I'm going to move out here to the front with the 1 over ln of 10, which would leave us with sine over cosine. And if you'll look at your identities page, sine over cosine is equal to tangent. So our final answer would be 1 over ln of 10 times tangent of x. Logs. And on example 2, I want you to remember, even though it's log base 3 instead of ln, we still have formulas or properties that allow us to split this up and make the problem simpler. So before you start working on the problem, you want to do a rewrite. Okay, remember, square root of x is the same thing as x to the 1/2. And when you have a power, you can move that to the front. So we're going to make this 1/2 log base 3 of x. And then division changes to subtraction. Okay, so we would subtract log base 3 of x plus 5. Now when we take our derivative, we're going to be able to take the derivative of each part separately, and that's going to be much simpler than trying to use the chain rule and the quotient rule in the original form. Okay, so log base 3 of x. The first part, we've got 1/2 times the derivative of log base 3 of x, and according to our formula, It's 1 over the ln of our base, which is 3, okay, times the x. Okay, and since it's just an x, I don't need the derivative of x because that's just 1 and that won't change anything. So now we're going to subtract, okay, 1 over ln of 3 again because 3 is still my base, times x plus 5. And technically we need to multiply times the derivative of x plus 5, but the derivative of x plus 5 is also 1. So that's not going to change anything. There's not really a lot of simplifying we can do here unless we get a common denominator. And right now we're just practicing formulas, so I'm not going to take the time to get that common denominator. I want you to get used to using the formulas first. Okay, now here are two other formulas that deal with integration. So we've looked at derivatives of e to the x, a to the x, e to the u, a to the u, ln or log base a of u. Now it's time to look at the integrals. And remember, integration is the inverse process of the derivative. And we're really only going to look at two formulas here, and that is the integral of a to the x and the integral of a to the u. Okay? So the integral of a to the x dx, remember that the integral of e to the x dx was e to the x plus c. E to the x is the only function that is its own integral and its own derivative. Okay. Now, because we don't have a base of e, we have a base of some other number, we're going to have to adjust our formula slightly, but we're still going to copy paste the a to the x, and then we need to multiply times 1 over ln of a. And remember, all indefinite integrals need a plus c because there could have been a constant on the end of that function before we took the derivative. If your exponent is not just a plain x, if there is some function there, then the adjustments are going to be made before you actually integrate. So you'll notice these formulas look almost exactly the same except for the a to the x and the a to the u. So the u is going to be taken care of when you're setting up your original integral. So let's look at a couple of examples. Okay, so 4 to the 3x dx, we're going to integrate this. Our u has to be our exponent, which is the 3x. And again, remember I said we were going to adjust this before we ever did the integration. So our du is where our adjustment is going to come from. If u is 3x, du is 3 dx. So in our formula we have the dx, but we do not have the 3. So if I'm going to adjust this and put the 3 in with the dx, then I need to put a 1/3 in front of my integral. So when I rewrite, I now have 1/3 the integral of 4 to the u du. Okay, the integral for a to the u. Okay, I'm going to keep my 1/3. And then remember I need times 1 over the ln of a. The ln of a would be ln of 4. And then I copy paste my 4 to the u plus c. But remember again, if we started the problem with x's, we need to finish with x's. And I can take these first two fractions and combine them into 1. 1 over 3 ln of 4 times 4 to the 3x plus c. And that will be my answer. On this next example, okay, it looks like we've got two trig functions, but remember again, if it's 2 to something or a to the u, your u needs to be your exponent. So we're going to let u equal the sine of x, which means du would be the derivative of sine. The derivative of sine is cosine x dx. So all of this is my du, and right here the exponent is my u. So this one doesn't need any adjustment at all. It's really in the form 2 to the u du. The integral of a to the u is 1 over a, or ln of a. In this case our a is 2, so 1 over ln of 2 times 2 to the u plus c. But we're going to finish out with x's because that's how we started. So 1 over ln of 2 times 2 to the sine x, that was my original u, plus c. Again, in these problems you're going to have a copy-paste situation, and you only have to adjust the 1 over ln of a. Okay, remember anytime you've got two functions that are added together, you can actually write this as the integral of x to the 4th dx plus the integral of 5 to the x dx. So x to the 4th is an integral we've been working with ever since we started integration. It's just a power rule. So we're going to add 1 to the exponent, x to the 5th, over 5. Okay, and then for 5 to the x, 1 over ln of a is 5, times 5 to the x. I did not have to make any adjustments because it was an x, not a u, and then plus c. And again, you could get a common denominator, but there's really not much you can do to that. You can take this term in the middle, and instead of 1 over ln of 5 times 5 to the x, you could write that as 5 to the x over ln of 5. Again, doesn't really simplify it much. It makes it a little cleaner, but it doesn't really simplify much. You could get a common denominator and see if anything simplifies. But we're going to stop there for now. Make sure you make your flashcards for the 6 formulas in this video, and put a question mark beside anything you need to ask me about.